Okay, so before we get started, right, I'd like to understand one thing, like how many of you all students here? Okay, cool. So the rest are working professionals. Okay, cool. So today, I think like we are going to like talk about AI agents. I am sure that you would have been like went through this AI bus for the long time, probably for the past 2 or 3 years, right? It's all about AI. So our talk is going to focus on what exactly is AI agents. Okay, so um, most importantly, we are not going to dive deep, but give a high level understanding of where we started, how the AI evolved, and where we are at the moment. So what kind of like made us to go to the spot where AI agent became a predominant technology with respect to the AI evolution. So that is going to be the crux of the talk. Um, So a little introduction about myself. So I'm Sakthivel. So I'm working as an application developer. So been with Equal Experts for almost 7+ months now. So before Equal Experts, I've been with various other MNCs and a couple of startups. I also have Naveen with me. Naveen. So he's also an application developer. So he's with Equal Experts. So okay, so let's get into the agenda. So before that, like a couple of things. So I'll go through the deck. I'll pass in between in case if there are any questions. And at the end of the session, we'll further discuss if there are any questions, queries, so on and so forth. So the agenda. So the first is evolution of AI, right? I think like it's a challenging time in terms of the technology is evolving a lot. So what we are going to talk about is how it kind of started and how it kind of changed the pace and what made AI so in terms of the usage, what kind of like made it to shoot up. So all those things we'll be talking about in the evolution of AI, and we also have a understanding of LLMs and RAG. So what exactly are LLMs? How it kind of like got traction and what is RAG? We'll be like touching upon those, and finally like we'll go into the AI agents part. So going through this stage will help you to understand what AI agents are, and it will help to mentally map how it kind of like evolved to the current stage we are in. I'll show a very small demo on agents. So it's going to be very small one because like we have a subsequent talk where Navin will be diving into the agent demo for the complete half an hour 45 minutes. And finally, we'll also get to introduce to the AI agent protocols. So this is not going to be a deep dive, but I'm going to like show you what are all the protocols that are out there, which is something for you to explore upon. So this is going to be the complete agenda for our talk. Okay, so the first things first. Is it clear? I mean, like, are you guys able to see? Okay. So let's talk about the evolution of AI, right? Like, let's specifically talk about the traditional AI ML. So what do you think was the traditional AI ML that was there before AI, before LLMs? There was AI/ML. Anyone interested to like talk about how it was before the kind of like LLM era came in? Yep. You can probably sit down. No problem. Mm, exactly. So you need training data for ML to understand what exactly it needs to identify, etc., so on and so forth. So one good analogy is let's say you wanted to identify a ball. So you have to give the system, like if it is round, if it is in this color, then probably it is a ball. So it has to identify that. So that's the way like we were doing before. So it is all custom pipeline, like unique data set. So if data changes, then probably you have to retrain. Cost is there, maintainability is there. All these challenges were there. It is all rule based. It is all statistical information based. So this is how the traditional AI was. And next, like we kind of transitioned to a phase where deep learning became more popular. So instead of rules, we came into an era where we'll be giving data, let's say like 10,000, 1 lakh or a million data, so that the AI can understand what exactly is. For example, like you wanted to differentiate between a cat and dog, so you'll probably give millions of images, so that even if something changes, the AI will be able to understand this is a cat, this is a dog. So that is how like deep learning helps. And then came in the phase pre-trained model. So this is all before probably like 2018ish, 15ish, that sort of timeline. So pre-trained models were specific for a particular domain. So imagine you have an insurance domain, finance domain, so the models will be trained for that specific domain where data related to insurance and finance will be provided, and they'll be able to tackle problems with respect to that particular domain. So it is all domain specific. And finally, we come into the foundation models. So any takers, or like anyone want to talk about like what foundation model is? Okay, no problem. So the foundation model is the foundation for everything we are doing at the moment, right? So we saw pre-trained model, which is trained for one specific domain. When it comes to foundation model, it is kind of trained all the on multiple domains. So when ChatGPT was introduced, right? So one of the important crux is that it was trained on the internet data. So internet is wide, internet is large scale. So everything was used to train, so that it has a general understanding of the whole world, which means like language, countries, culture, so on and so forth. So it has all the information in it. So the foundation model can be used for other use cases. So that is a foundation model era, and this is going to be an important term. Probably you folks can remember, because all the things that we see today, either it is ChatGPT, GPT, Claude, everything is kind of derived from a foundation model. Okay. Yeah, we talked about it, right? Like foundation model is trained on vast and diverse data sets. It's kind of like billion. We can even say like trillion at the moment. The some of the model providers have stopped giving like what's the number of parameters that they are using. So all the internet data has been like used in the pre-training phase for the foundation model. Um, and as I said, right, we are helping the model to have a general understanding of the whole world. So the patterns involved in the world. So what is the generalized task we will be doing across each domain? So that's what like the foundation model is. Uh, the important advantage with this foundation model is that you don't need to pre-train it again and again. So when I mean like pre-trained, right? So once you make a pre-training with a large scale data, so if you want to adapt it into a particular domain, you can do a very little or minimal fine tuning, so that it will be able to do tasks in your particular domain. So that is one major advantage with foundation models. Um, yeah, any I'll just pause here for a minute, probably like in case if there are any questions, we can take it now. All right, cool. So let's quickly like see what's the major difference between traditional and foundational models. So it is single purpose, as I said earlier. It is used for like a particular domain, unique data set. Performance will be challenging because you have to like retrain in case if your data changes, and similarly like it will be expensive to maintain. So whereas foundation model, it is multifunctional, it can cross cut across domain, and it is also cost effective. So when in terms of cost effective, right, initially we did not get a chance to use these models through paper usage, but now like we are able to like make use of it, either it is GPT, Claude, or any models, right? So that's a major difference between traditional and foundation models. Okay, moving on, a little bit of history. So do you guys remember like what happened in November 2022? So what kind of what released in November 2022, to be specific? ChatGPT, right? Okay, fantastic. So so GPT again is a specific language foundation model developed by OpenAI. So ChatGPT wasn't released in 2022. because the model existed even before that, like 2017, 2018, they released their first model, which was having 100 million parameters or something. Then they kept on like increasing the parameters. And more specifically in 2022, what they did is they opened to public. Okay, when I say open to public, so they made it as a conversational interface and they made it free for the public to explore. Okay, and it is not for developers alone. So if you think about it, any domain, any person will be able to make use of chat gpt. It's just a chat, right? We've been like used to chat for a longer time. When the first mobile was introduced, we were using sms and all those things, so we were introduced for chat for a longer time. And when you are able to like talk to a machine without googling anything, and if it is giving you an answer, it kind of like got the niche area, and the people were so used to chat gpt, and it kind of blew. So that is one important thing. So why I am talking about it, so let's talk about this, right? So that's a triggering point for everything that we have today. So be it llms, be it rags, be it AI agents, so the conversational way of talking to AI introduced us to many big paradigms, and there was a very like broad change in the technology landscape itself. So this kind of like brings us to the point of LLMs. So anyone wants to like talk about what an LLM is? Probably like we talked about foundation model. Any takers on LLM? Okay, so LLMs are nothing but foundation models. The only difference is that so LLMs have been trained with language specialization. So if you want to talk in English, or if you want to talk in any language, right? So it needs an additional pre-training along with the already trained foundation model. Okay, so that is the important difference between an LLM and foundation model, right? So it is a subset of foundation model per se, but it has been like specially trained in a particular language so that it can process, understand, and also like generate output for the language that you are trying to talk to. So that's the reason like it's called large language model. So it's kind of like specialized in the language. And when LLMs are being trained with large set of data, right, wide and large scale data, interestingly, LLMs start to exhibit some behaviors, some capabilities. So what are these capabilities? So I want to like stress upon here, it is not explicitly programmed, but when you like scale LLMs to wide range of data, when you are like training with wide range of data, they start to exhibit some certain capabilities. So those are called emergent behaviors. So it is not programmed, it is not trained, but it starts to like show those features when it is trained with large or huge amount of data. So if you take ChatGPT, right? If you I mean, like it has evolved a lot, but initially like 2022, so it was able to like give you any answers in any domain in any question. So in fact, like you would have seen certain Twitter posts or Reddit posts where certain people were able to diagnose with the help of uploading their scanned reports. They were able to understand, okay, what exactly the disease was, and such and so on and so forth. The news we are all hearing, right? So these are some of the characteristics of LLM, which is exhibited only if we train with a huge amount of data. So what are those characteristics? So again, like, so it's kind of like it's not alone like performance improvement, but they are entirely new behaviors that appear only at scale. So some of the emergent properties, right? The first thing is, so you provide a prompt. Okay, so the first use case that we talked about is LLMs will be able to give you the answer that you are like putting forth. In addition to that, if you give a structured prompt, if you want LLMs to do things in a certain way, it will be able to understand and it will be able to execute it. It will be able to try and execute it. So that is one of the important emergent properties. So again, I'm saying like this is not explicitly programmed, but these are all characteristics that comes when it is uh, trained with a large amount of data. Uh, and it also can do chain of thought processing. So what is chain of thought processing? If you have a set of tasks that needs to be done, so what LLM can do is like it will execute one task, it will validate whether the task is right, again based on the data it has, again based on the training it has done, and it will compare and it will proceed for the next task. So these are all the characteristics that emerge. And finally, it can also do simultaneous tasks. For example, one foundation model can do summarization, it can even help you with translation, it can even help in question and answers. So these are all the emergent properties that arise with LLMs when it is scaled to a huge amount of training data. Okay, so a quick recap, right? Like we discussed about traditional AI, we discussed about like foundation models, we discussed about LLMs. So what's next? Okay, so you put one question, you get an answer, and okay, all fine. But the next evolution happened in this particular spot, right? Now you go beyond one step and you wanted to get answers, summaries for the data that you have. So this is not only your data, but it can be an enterprise data as well. So some of you might be like working in an organization, right? You will have employee information available, you will have salary information available, finance information, insurance information. But how can you like make LLM talk to those data and answer questions or summarize whatnot is the next kind of evolution that happened. And like that is where RAGs come in. So RAGs is retrieval augmented generation. Again, like that's a full form. Anyone wants to talk about it? Probably like RAG is a famous term, right? I mean, like, you can probably try out what a RAG is. So far, I'll be good. I mean, like, are we on the right track? Okay, cool. So RAGs, as I said, like retrieval augmented generation. So LLMs, if you take, right, like LLMs will be pre-trained with large scale data, but it will not have an enterprise data or like contextual data. So for your organization, the data will be different. For the other organization, the data will be different. So it will not have contextualized data. So that is where RAGs comes in. So what it does, so it has like three major steps. So one is retrieval phase, so the other is augmented phase, and then the third is generated phase. So you have, okay, let's take this as an example, right? So you have hundreds of PDF files that is available in your organization, maybe like hundreds of Word documents, and now you want to feed that data into a large language model. So how do you do that? So you have to have some means so that you can convert the data into one particular format which can be understood by LLMs, and LLMs can probably like talk to the data. So that is where the RAGs come in. So what RAG does is, so when you put out a query, right, like when you put out a query, so all the PDFs, all the Word documents, all the documents that is available in your organization will be converted into a vectorized query or like a vector points, and then it will be fed into the LLMs. So along with the foundation model knowledge that the LLM has, this is also an additional input that will be given into the foundation model so that the AI can make sense of the context that you are querying. For example, like if you wanted to understand how many employees, active employees are in your organization, based on the data that you have fed and along with the foundational model capability, it will be able to analyze the vector points and it will be able to give you the response. So in a gist, like you retrieve the data from the knowledge base, you convert PDFs, Word document into a vector points, and you augment it with the foundation model or the LLM that you will be using. And finally, the AI will take care of generating the response for you. So that is where the RAGs comes in. Okay. Uh, so we talked about traditional AI, pre-trained models, and then like we talked about foundation models and how language specific models are trained on top of the foundation models, and finally the retrieval augmented generation. So do you guys think it kind of stops here? Okay, so why it doesn't stop? I mean, like most of the problems are solved, right? Like of course AI has its own like drawbacks, etc. but you are able to like talk to AI, you are able to talk to AI with your enterprise data. So all these things are solved. So what's missing now? What's the missing piece? Hmm? Standards. Okay, standards is a good point. We'll come to standards for sure. Hmm. 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 Right. So good point. So like until RAG, we were able to like push data from the PDFs, the documents that you have. But one important point that you mentioned is Gmail, right? Like so, it's an external framework or a tool or a system, right? So how do we make AI talk to it? So that's the kind of like starting point for AI agents, right? Uh, I mean, like so until RAG, it was fine, but there were some limitations until RAG as well. So one of the main drawbacks is the context windows, right? So how can you make AI learn from the past interaction? So you keep on feeding the document data, you keep on making the AI to like talk to you, but how do you like help AI understand what mistakes it has done in the past? So how do you make sure that like because the context windows are limited for the current scenario or probably the scenario until we talked about. And the other challenge is autonomous decision making, right? You get output, but there is no decision making capability available with the AI. That is one of the important crux of the next phase with AI. And finally, like if it is complex workflow, how will you orchestrate those workflow? So one task is done, the second task is done, the third task is failing. Maybe you want to decide which task to be done after that failing task. So how can you orchestrate all these things? So that is where like the agent comes in. And finally, how will you get access to the real time data? So rags help in like loading the PDFs and all those things, which might be like historical data. It can be even like 1 week past data, right? But how can you like interact with real time data? Real time data, like it comes with API and other integration layers, right? So how can you make AI talk to those layers? So that is where the agents comes in. Right, exactly. Yeah. Yeah. Yeah, very important point, right? Like we have transition from human taking a decision to human reviewing the decision. So human, still the human loop will be there, but they kind of like transition. Right. Yes. Exactly. Yeah. Good point. Okay, so it's again like a kind of a class book definition, right? Like you don't need to take the entirety of it. So AI agents in the crux, it can like reason about the goals that you want to achieve. It can make decisions, and it can even execute actions. So that is the crux of it. So until RAG or until the conversational AI was there, you were like the initiator. You were getting some response, but you got the response. But what do you want to do with that? Like there will be like tens of tasks that needs to be done after that. So that is all like stopped until RAG. And now with agents in place, so you can do all those things. So that is where the AI agents comes into picture. In simple words, right? We saw like its goals, decisions, and actions. In simple words, when LLM is augmented with memory, knowledge base, tools, planning metadata, it kind of like transitions into an AI agent. So memory, so you want to like keep track of where the AI failed, where it succeeded, so that you can learn from the data that is there. Knowledge base, you continue to keep feeding knowledge, and tools. So tools is where like API, database and other integration layers comes into the picture. And finally, the planning metadata. So planning metadata, you want to give instructions to AI on what it needs to do and what it need not do, and all those prompts and other things comes into the planning metadata. So in a crux, when LLM is augmented with these things, it becomes an AI agent. So there is nothing new in terms of AI agent. So I mean, like, LLMs were already existing, a couple of years back, and AI agent kind of like helped streamline things so that more workflow, more tasks can be done with already existing technology, or like the LLMs that we have. This is a very simple, high level, arc diagram for an AI agent. So you need not like take this for granted, because contextually things might vary, but on a high level, right? So we'll have an orchestration layer. So an orchestration layer can be LangChain or anything. So it will have access to all the components that we saw earlier. So most importantly, it will have access to the LLMs as well. So planning metadata. So as we talked about, it will have the goals, rules, so on and so forth. Memory, to store something what AI has learned, so that it can like extract again and understand where it kind of like went wrong, and then it can course correct. So tools, APIs, databases, third-party information. Uh, so you are giving a way for the orchestration layer to talk to data real time. And finally, the knowledge base. So knowledge base is important in terms of an enterprise perspective, right? Okay, so we saw all these things, and now is the agentic AI era. Uh, LLMs with memory and tools use. So without memory and tools, LLMs were answering question, but with memory and tools, it can do more than that. Multi-step reasoning and planning. So you have like 10 tasks to be executed. So it can learn from one task. It can like decide which task to go on. Multi-step reasoning is a key to it. And finally, it can take actions and decisions. And of course, it is up to you, right? Like agent can be fully autonomous, or agent can be made semi-autonomous, or it can even be not autonomous. It is up to the context, and it is up to us to decide what perfectly fits in particular use case. Okay. All right. I'll probably like show a very simple demo. I mean, like, so this was something that developed on the fly. But before we go in, like any questions, any thoughts? Yep. Right. So it is preventable, hallucinations. So it is not entirely preventable, and leading organizations are working towards minimizing the hallucinations. So I don't think like we'll be able to get to a spot where the hallucinations will be fully like eradicated, right? So we talked about emergent properties. So when these emergent properties are arising, so does hallucinations as well. So there is lot of chances the AI can go wrong, that can give you like plausible information, like incorrect information. So all the leading models are trying to reduce the hallucinations as much as possible. I mean, like it's a complex topic. Like it is all done through mathematical function and all those things. But 100% I don't think like we'll be able to reduce hallucination. We can improve it. Yeah. Right. Probability distribution is. Exactly. Yeah. Hmm. I mean, it all boils down to the data we have at the hand, right? Data is not perfect. I mean, like even though how much perfect we try to like make it, it will always be imperfect. So right. All right, any other questions? System problems. I'll probably like give a very high level. Hmm. Okay, so I'm going to like give a very high level idea on like how we can use agents, right? So we saw that architecture diagram. I'm not going to like dive line by line, but give you a very high level overview of what we have done. Uh, so how many of you are okay with Python? Most of you, right? Like, yeah. See, I'm not getting into the syntax and all those things. So ideally, so imagine the architectural diagram that we saw. So we'll have an orchestration layer. The orchestration layer will talk to tools, memory, and LLMs, right? So consider this app.py to be the orchestration layer. So it's a starting point for the app. Any app will have a starting point. So this will orchestrate the communication or the collaboration between the different agents. And the agent that we are going to like show is code review agent. So how many of you are aware of code reviews in organization? Okay, so are we doing the code reviews properly? Okay, that's a question probably. So code reviews, it's pretty straightforward. So in terms of people working on the code, we want an extra set of eyes to be used to see if there are any gaps in the way of the development that happened, right? So what we are going to do is we are going to showcase something similar to that. So we have a bug detection agent. Unknowingly, like you are pushing some code, it has some bug. Of course, like humans will not be able to identify that during the review as well, but we are going to use an agent for that. Similarly, like code review. So it again like goes through the code review, checks the syntax, probably like in case if there are any deviations in styles and etc. That's going to help us out. Security scanning. Accidentally, if you have pushed something bad or outdated packages, it will help us to resolve that. Test assistant agent. It will help us to improve the test coverage, or maybe like for some scenarios, if testing has not been done, the coverage has not been done, it will help us. So again, like this is a sample one. This is to like share the idea behind agents. So it is not directly integrated to GitHub, but you can easily do that. So it is now using mock data. But ultimately, this will be making a call to LLM with the mock data that we have, and the LLM will be able to give us response. Okay. Um, is it okay? No? Okay, so let's probably like take a look at what this code review agent is. And if you see here, so the code review agent has a set of methods. So the first is, let me probably like collapses. Yeah. So it has like a set of methods. So first one is like analyze pull request, analyze code file, generate summary, generate recommendation. Review history, review metrics we can ignore for now. So what we have in analyze pull request. So it's just that like it is pulling the pull requests from GitHub. So you can even like integrate with webhooks so that any PR that gets created, automatically the agent can get running. And we'll also see the next one, analyze code file. Okay, so if you see here, we have an analysis prompt. Okay, so it all kind of boils down to the prompt. So you are like setting up this prompt in the agent saying that, okay, analyze this code file for clean code principles and best practices. So what do you want the LLM to focus on, like code readability, naming convention, and so on and so forth. And you are passing the file name and also the code content. Okay, code content is nothing but the changes that you have incorporated. And you want the summary to be in this particular format. Again, like this is kind of like going in as a prompt. So code quality assessment should be given with a quality, like what's the percentage score based on the LLM's evaluation and how many issues it identified, and you want this to be formatted in this format. Okay, so that's the same kind of structure we'll have in other areas as well. Okay, so any questions? All right, cool. So what I'm going to do is now I'm going to run this application. So I'm using Streamlit for this. And so these are all mock data. So if you see here, like we have a bunch of repositories. I'm going to like use this e-commerce sample. So in the last PR, imagine that like we have this particular code changed. We have auth service, we have like auth models, so on and so forth. And I'm going to like run all the agents. I'm sorry about that. So now when you run, is it okay? Somewhat okay? Okay, so yeah, this kind of like running in local. And if you see here, this is making an API call to open router. And this is the system prompt that's going in. So it is setting an expectation for the model on what it should behave like. So you are an expert code reviewer specializing in clean code review. So analyze the provided code and return a JSON response with the following structure. So you are saying you are like giving all the metadata to LLM. The code changes. What is the kind of review that you want it to make, and what is the output structure that you want. So now imagine like this being one particular agent, right? So you will be like having manifolds of agents, and it will all be like doing exact thing talking to LLMs. And once after again, like this is system prompt. Yeah, Rajesh was talking about it, right? This is system prompt and setting the expectations, and then like this is the user prompt. The user prompt will be dynamic, and this is where the actual code change goes in. And if you remember, we saw that, right? The code to analyze and all these things it's going in, and this is the response that it gives from the LLM. So it is saying, okay, the secret key is being stored directly in the auth service instance. Like medium error handling. So these are all like medium ones. The verify token method catches exceptions without logging. So these are all the analysis that has been done by LLM and giving you a structured response. Yeah, so that is code review, and then like this is bug detection, and this is security vulnerability scanning. So all has similar prompts, but you get the idea, right? Like you can have any kind of prompt that fits your organizational context, and you should be able to build agents on top of it. Yeah, finally, like comprehensive test cases. Again, like you want the LLMs to evaluate whether the test coverages are all good or it needs to add additional tests, so on and so forth. Okay. Right. So this is where the LLM client is in, and so all the code that we saw, right? Like it kind of like analyzes the code. So imagine this to be the tools that we saw earlier. So that will be connecting to the the LLMs that we saw earlier, that will be connecting to the open router, and it will be like making the communication through API. Okay, cool. So moving on. Yeah, I want to probably like end with um, one last point. So the protocols, right? Okay, before we get into the protocols, any question? Yeah, please. No, there is no. Yeah. So I think like see we have to like differentiate these two things separately, because so system prompt is the set of expectations that you set for the LLM to be performing whatever the prompts that are coming in. So it's kind of like preparing it. You are kind of like bootstrapping the LLM to answer in a structured way. Okay. So these two are different things. So user prompt will be dynamic. Okay. But system prompt will not be dynamic. So you are like setting the expectations. It's kind of like an enforcement that you are putting forth as a system prompt, and you want the LLM to be behaving in this set of instructions for all the system prompts that will be coming in. And if there are chances where the system prompt can also like take sorry, the user prompt can also like take system prompt kind of things, right? For example, like like there is a set of rules that have been given in system prompt. You are overriding the rules through user prompt. So again, like if those chances might come in, you have to like modify the system prompt so that it will ignore all the rules that are coming out. So LLM, it kind of like acts on vector points. So it doesn't know the context. It kind of like takes action based on the prompt that you are going to give. So you have to create all the precautionary in place so that it is able to like not deviate from what the system prompt is provided. So I kind of like deviated from the answer, but you get the crux, right? Right. Hmm. It's a dynamic one, yeah. Hmm. 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 It will be single prompt only. Yeah. Right. For our understanding, probably, but it will all be the same for LLM. So it doesn't have any context. It will all be the same. So for our understanding, we are kind of like segregating it so that you can limit the hallucinations. At the end of the day, it won't confuse itself. Or maybe you can preload it from some place else as, so you don't have to like it's again like a way of things, right? Right. Okay. Yep. With respect to the code you are asking. Okay, cool. Okay. Hmm. So, okay, so this is the response that we have received. Okay. So, for example, okay, let's come back to this. Probably, I'll just complete the. Sure, no problem. Yeah. But I think like but the idea is, like we have this. I'll just like take 2 minutes probably. The idea is like you have an orchestration layer. It can be anything, as we talked about earlier. So you're talking to LLMs. You need memory to be loaded. You need to talk to tools. You need a knowledge base. So this is the 30,000 feet level, right? Exactly how we are doing with agents is, again, we have like different paradigms. So I showed that sample for you to have a very high level understanding that you know any use case can be adopted to agent, so that like with the help of prompts you will be able to execute tasks. So that's the idea behind it. But we'll discuss on this. So finally, like I wanted to like quickly like show the available agent protocols. I'm not going to deep dive into it. So first is MCP. I'm sure like many of you would have heard about MCP, right? So we talked about tools. but we need a structured way for talking to those tools. So MCP gives us that standardization. So it has client server model, and then like if you go through the documentation, you will be able to understand how it can properly talk to each other. So A to A, agent to agent communication. So we have multiple agents. So we had code review agent, we have bug detection agent. What I have shown you in the sample is kind of like a series of agents. So the first will execute, the second will not worry about the first response. Again, like the third will not worry about the first two's response. So it's kind of a series agent. But what if you want the agents to talk to each other? Okay, so the bug detection agent will be giving you a couple of bugs. Maybe the security vulnerability will also be related to that. But if you want the agents to talk to each other and give you a summarized view of what went wrong or probably what are the problems, you need the agents to talk to each other. That is where like the A to A comes into the picture. This is developed by Google. AGUI, for UI, there is also a standardization. This will provide consistent UI experience. So we can write agents in many ways possible, but this kind of like solves most of the problem already for you, so that you can use that standardization protocol. Finally, like ACP, this is kind of like recent. So this is a protocol helping us to like structure the message in the right way. So you saw the logs, right? We were like creating system prompts, we were creating like user prompts, and it was like passed on to LLMs, and we are able to get the response. But ACP helps to ensure that the structure is based on the standardization that they have provided. So this is again like low level detail. Why this is important is because many of the tools will start supporting this protocol, and if you learn and if you adapt to this protocol, you will be able to easily integrate with systems, integrate the AI agents. All right, I think like so that is all like we wanted to share in the first session. I know like we've been discussing a lot. Any additional questions? Yep. You can probably. So the LLM has to support the multilingual first hand. We might need separate agents. So if your LLM supports that, so you can have a separate agent uh, for you to like process in the language that you are expecting. But if your LLM is not, then probably you have to talk to multiple LLMs. So that's why then you can talk to yeah, you see, that's why like this has been put in as LLMs, right? LLMs, you can talk to multiple LLMs. It's need not be like one particular LLM. So the orchestration layer will decide, okay, this is a multilingual question, or maybe if you want these particular things to be going into a particular LLM, then you can probably do that. So there is no restriction. Yep. Uh, okay, can you repeat it again? Sorry. Hmm. You can create a separate agent for that. Okay, so for example, I'll just try to give or like come up with some use case. So you are like we will have this in the same example itself, right? So bugbot, the file that I shown is a separate dedicated agent. So bugbot detection is a separate dedication agent, and ultimately it is kind of like calling the same LLM client GPT. So all these four things that we saw, right? Like it is all calling the same GPT, same model. So you can have another agent if you want this to be like responding in Tamil or probably like in different set of languages. So you can have a separate language, and this is where the A to A comes into the picture. So if you want this agent to load data from the previous agent, etc., etc., So those kind of integration you can make, and you can like get things done on what you want it to do. So it is all like see, I think like the idea is you have an orchestration layer, and you are free to extend it in any way possible for you to like solve the business problem. At the end of the day, we are solving some business problem, right? And these are all the tools, capabilities that are available. And if you're able to solve in one way, I think that's how like it's. Okay, cool. Rajesh. Thank you. Thanks, guys. I think it was a very interesting